range of values
like this, it means that
be satisfactory in the graph. No, for this problem. To solve this, we say y equals to 2x plus 3, just so that we can get the line that this is trying to tell us about. Say y equals to 2x plus 3. Now, we're not using the word equal to here because of this equality sign. It's just to know what graph this might look like. So even if we had this kind of problem, y is less than 2x plus 3, or y is greater than 2x plus 3, we're still going to start by saying that y equals to 2x plus 3. We just want to see the line. When we see the line, the kind of inequality we have, whether it is a strictly greater than or less than, or an inclusive kind of inequality where you've got or equal to, will tell us whether the line is part of the solution or not. Obviously, in this case, because it is less than or equal to, tells us that even this equation of a line is a part of the solution. But if you had something that says y is strictly less than 2x plus 3, the line is going to guide us, but the line is not going to be part of the solution because it's not or equal to. So what's this line? Remember what we talked about, where we said if you have an equation of a line, it's so easy to plot the line once you know the intercept, which is 3 in this case, and you know the gradient. So with the gradient, you know what x and y's will be at several points, but you only need one more point because you already have 1 point. So when x is 1, what is y? 2 times 1 plus 3, that's 5. So if this is 5, then it means that, okay, this is another point on the line. And once you know 2 points, use a straight line, use a ruler to plot a straight line. So that is the line y equals to, sorry, I shouldn't have done that. Now, that's the line y equals to 2x plus 3. Is this line part of the solution? Should we shade the line as well? Yes, it is part of the solution. So I will shade the line. Now I'm going to shade. So if you were to draw this in the exam, you probably want to use a pencil first. Now, what happens if the line were not a part of the solution? We wouldn't draw a solid line. We're going to draw a dotted line to show them that, well, we're just using the line to guide us, but the line is not part of the solution. So here we're drawing a solid line because we know that it is or equal to. So that means y equals to 2x plus 3 is part of the solution. Now let's look at this other side, which says y is less than or equal to 2x plus 3. It tells us that either of these two divides of the line will be a solution. So either this part is a solution or this part is a solution. Now the only way to know that, because there are many shortcuts around, but the only way to know that really is to play with any of the points on any of the divides. If I choose any point here where x is 1 and y is 0, or if I choose a point here where y is 0 and maybe x is minus 10 or something, if it agrees with this inequality sign, then it's a point. Then I'm going to shade the entire region of whichever the two agrees with the equation, with the inequality. So the easiest for me to do is to play with this origin, because the origin is obviously on one of the sides. So if the origin meets the condition, then all these sides will be shaded. If the origin fails, then all of this region will be shaded. So let's test with the origin. Okay. So y less than or equal to 2x plus 3. When the origin tells us that when x is 0, y is 0. So the question now is, what does this mean? 0 and 3, right? Is 0 less than or equal to 3? Yeah, 0 is not greater than 3. 0 is less than 3, so it is less than or equal to 3. So that means that the origin is agrees with the inequality. So if this origin on this side of the divide agrees, then that means every other part of the divide on this side will agree.